Okay, looking at the vapor pressure again of ideal solutions, this is a little bit different because now we're going to be talking about two volatile components. Previously we dealt with where you had one volatile component and something that was non-volatile dissolved in it. So when you have two volatile components, then the vapor pressure of the solution is going to be equal to vapor pressure of solute A plus vapor pressure of solute B. And you can have as many solutions as many solutes as you have in the solution, so that's fine. I'm just giving an example of two over here. So the vapor pressure of solute A, that's going to come from then the mole fraction of A, and the vapor pressure of A, and then the vapor pressure of solute B is coming from the mole fraction of B and vapor pressure of B. Okay, so once you get the individual vapor pressures of each of them, then you will add it up to get the total vapor pressure of the solution, and that's what happens when you have two volatile components. Okay, so each one is contributing its own vapor pressure. So here is the question for us. Okay, at 25 degrees Celsius, the vapor pressure of pure benzene and toluene are 5.1 millimeters Hg and 28.4 millimeters of mercury. The solution of equal moles of fraction of each, so equal mole fraction of each benzene and toluene is prepared. What is the vapor pressure of each solute and the total vapor pressure? So the mole fraction then, okay, so the moles of each is going to be 0.5 because total is 1 and each is half. Okay, and so if each is half, then that is 0.5. So that's 0.5 moles. Okay, so which means that the vapor pressure of benzene is going to be the mole fraction, which is 0.5, then 0.5, and the vapor pressure of benzene is 95.1 millimeters of Hg, which is equal to 46.6 millimeters of Hg. So similarly, vapor pressure of toluene then is also going to be 0.5 because that's the mole fraction times 28.4 millimeters of mercury, and that gives us 14.2 millimeters of mercury, which means that in a solution where you have equal moles of benzene and toluene, each of them are contributing this much of vapor pressure. So then the total vapor pressure of the solution is going to be the vapor pressure of benzene plus the vapor pressure of toluene, which really is equal to the addition of these two over here, which is then 61.8 millimeters of mercury. So a fairly simple calculation. The only thing you have to do now is if you have two volatiles, you have to calculate the mole fraction of both and then add both. And you can see that the vapor pressure that is contributed then is kind of in the middle of 95 and 28. Okay, it's not higher or lower than either of them because each of them is contributing for the mole fraction here. So just a little tidbit over here that if you're given masses, if masses of two volatiles is given, then convert to moles. Okay, that's all you have to do. In this case, the mole fraction was already given to you. So convert to moles, find vapor pressure of each, and then add. Okay, as given above. That's it. All right, fairly simple to do.